Hello everybody, my name is Callum. I am the team captain of the Scrappers, a combat robotics team from Norfolk in England. And in front of me is BAW, the original. The original BAW one from 2017 that has run for the past 3 years at almost every competition we've been to. From the extreme robots with the melees, to Robo Dojo with the singles combat, to even Robo Nerd where it was on display with a lot of modern and classic things from the TV show and the live circuit. But this robot is 3 years old. It's got a lot of battle damage, particularly on this front bit here and the big hole. Thank you, Pressure Point, for that one. So I think it's time for this robot to be retired. But rather than just throw it out there to be smashed to pieces by some spinners, which to be fair I did consider doing, it sounds like fun, I'm going to try and salvage as much as I can from this and recycle it and build a new robot, something much smaller, but also still just as simple, to prove that really anyone can do this, because this was built on a budget of I think less than £300 because I'm a student and I don't have the money for all the equipment and machinery and fancy metals that everyone else uses. But we learned some things from our first go around, so let's see what we can do to improve this, and we'll start by taking a look inside. So this is the internals of BAW1, and as you can see it's a bit of a mess, particularly this cluster of wiring here. Now before building this I had literally zero experience wiring electronics. I have never done anything of the sort, and to be fair, still to this day my only experience has been the robots we've built. And that resulted in this. Now what we've got in here is some motors and gearboxes straight out of some Argos cheap drills, like this, but it costs a lot less because that drill cost far too much to tear apart. We've got a speed controller, which I believe came from Rory of Team Nuts, but I don't think these are actually in production anymore, so if it breaks we have to find a replacement. We've got our radio receiver, we've got our battery, we've got our fuse, and we've got our safety plug. That is pretty much all the key components of any robot. So let's bring this a bit better into frame, and then I will show you a close-up of how each part works. So now we're a bit better in frame, let's talk you through the circuit we've got going on here, starting from the battery. Now this is a standard LiPo battery. You can get these from any, well, remote control, boat, car, plane, etc. shop, or probably some other places as well. This one is a Turnigy Nanotech 2.65, which is a 2650 milliamp at a 35 to 70C discharge rate. This is high discharge because this is what someone had recommended to me at the time, so we went with it. Originally we were using a much smaller battery, but that was too small. It just was not going to last a full 3-minute fight, plus the time to load up, get in the arena, and then get back out again. So we swapped to these. And as you can see, everything in here is held in just with some random strips of metal, some bolts, and for padding, just cut up kitchen sponges, just to stop everything banging together and breaking so easily. Now this method isn't ideal. As you can see, there is a bit of a dent just here in the middle of this battery, which is purely from this pressing down on it. So that is something we learned to change. But let's follow the circuit round now. So we follow the positive red wire through here and to the next part, the fuse. In here is a standard, I think, 30 amp fuse, possibly 40, I can't remember. But that is basically a safety feature. A fuse is in there and it is lower than the total capacity or the maximum peak capacity of this, because we'd much rather this burns out than this, because that's expensive and flammable and dangerous, and those cost literally pennies and will just go and not damage anything else. So following round we have the safety plug, which in this case is literally the plug out of a lawnmower. Give me 1 second and I'll grab the other half and show you how it works. Here is the other half. As you can see, it is literally just the plug out of a lawnmower, but with a loop of cable going from one side to the other, and then a cable tie around it just to make it easier to pull out because, well, safety. So this is literally a 250 volt 10 amp plug and goes in there, which I'm not going to do because this would then be a live circuit, and no, not at the moment. Following the circuit round, we come back out of here on this random brown wire because I didn't have any of the right colours, so why not? And then it splits off. Here we have the red wire going out to the power LED, which is the other thing I did not mention on the overview. Now, power LEDs are a good way to know if your robot is turned on, if there is any power throughout the circuit, and are a safety requirement, much like the fuse and the plug. Basically, if you're in the arena and you get hit hard and you stop moving, if the light's gone out, you know your circuit's broken. If the light's still on, well, then you've got a bigger problem. So that wire then follows through, and the red wire goes to this, the ESC, electronic speed controller. This controls the power going to each motor out of these wires here, and is essentially the brains of the robot. That's what makes it drive when I push the sticks. Now, obviously, this connects directly to each motor, which again, as I mentioned, are literally just out of an Argos drill. They are cheap. They were, I think, about £18–20 when I bought them. I think the price went up slightly because they changed the model of drill or something. And these are mounted in with some mounts that I got from a fellow roboteer. I believe these ones were from Alex, who you may know from Team Nuts or any of the other crazy stuff he's done. But the new ones I have are made by Roboteer Nat on the FRA forums, and there will be a link to the FRA forums in the description if I remember to put it there. And the newer ones are more sturdy, because these we had problems with bending, hence the cable ties around the top. If you put too much pressure on these or you get hit at the wrong angle, they can bend apart, and well, then these can separate your motor and your gearbox. Because on the front of these is a full gearbox, basically the one out of the drill, except you turn the torque setting all the way up, and then in our case for a while, hope it doesn't come undone, which quite frankly was one of the stupidest things we did in the early days, and we lost drive in multiple fights because this would come undone, this little spring you can see here would pop out, and the bearings would come out of the gearbox. Oh well, you live and learn. So if we follow the black wire back out, it goes round to here, and this is where the LED rejoins. Now the LED came out over on this side, just after the safety plug, and then rejoins just before we go back to the battery. This means that as long as the plug is in and there is power, there will be light. But if there is no plug in, the light will be turned off. Safety features, they're important. And then it follows back round to the battery, which means we're back where we started, and that is a complete circuit. One thing I didn't mention, the radio receiver. This little thing pairs up with your transmitter and it receives the signals which it puts through there, which then go to the motors and allows you to drive. Simple, really. When I push forward on the sticks, this receives a signal which puts it into this, which converts it into movement in these. There you go. So that is the entire internals. As you can see, it's really not that complicated. It just looks a mess because we didn't know what we were doing with wiring and basically made it up as we went along. Bad idea. Plan things out better than we did. Now with that said, I think that is the entire internals done, so it is now time, after 3 long years of combat, to slowly begin taking this apart to recycle into something brand new. One last thing before we tear apart years of combat damaged robot is just to point out something we learned upon building the newer versions, because you will have seen in our fight videos BAW 2 and 2.1, which I have in my hand here. And one thing you will notice is the pure size difference. 2.1 fits very neatly, well inside about, what, almost half the area, from front to back, side to side. If I put it at the very front corner, you'll be able to see, hopefully better. Yeah, all of this was just unnecessary. We didn't know how big to make a robot at the time, so we thought, hey, why not go for the biggest thing we can fit in the weight difference? So we did. But of course, people working in metal is heavier. Even this is a rather large for a metal featherweight. So I guess this new version is going to be a lot smaller, and we'll see what we can do with it. To once again show just how simple the original BAW was, everything is pretty much held together with these little tiny short wood screws. And that's because once you take out all of these screws, these ones at the front here held the wedge on, these ones around the side held the panel on. Once you remove it, the inside is of course just wood. This wooden chassis was designed because 1, it was cheap, 2, it was lightweight, and 3, because we were in part following Jono's video on how to build a featherweight for under £200. Another thing that will probably be linked in the description if I remember. If not, on this channel there is a playlist of some 220 something videos from different people on how to build a combat robot, just for your consideration. But as you can see, on the underside here, we have all of these carriage bolts, and these make up the mounts you saw inside for everything. If I lift this up carefully, all of these up here on the top of frame, they're all literally just these carriage bolts, and then they're held in by nuts on the other side. Up here we have 8 little hex bolts, and these go into the bottom of the motor mounts, the only thing that uses a different type of mounting. One other thing I would like to point out is that the actual wedge is in pieces. This was the wooden wedge that sat on the front here to create the actual wedge shape. And this was made using, I think, a hacksaw, and luckily we had access to about a 20-year-old router to carve this line down the back here, which I don't think we've used since, so it's, I guess, well done for finding a 20-year-old tool. As you can see from this one though, these were all really heavily glued in place as well, and this was because this half broke off, because this was on the side that got hit by, I think, the featherweight version of Apex, which, yeah, it shattered the wood. So we had to glue it. Glues and wood screws, that's what holds this combat robot together, and it's lasted 3 years without really that much structural damage outside of the wedge. With that said, let's remove the rest of these internals, and then the chassis will be completely torn down. Now I have one of the drive units out, I can actually give you a bit more of a close-up on how these work, because, well, they look more complicated than they really are. As I said a couple of times now, this bit here on the inside is just a motor and gearbox out of an Argos cheap drill. Those are commonly used because they're so cheap. They are one of the first things that are recommended to any new person getting into this, and were recommended to me by multiple people because of the price point. I've just attached a couple of wires to the pins on the back of the motor so I can plug it into stuff, and then solder the connector onto the end. As I said, these mounts come from a fellow roboteer and just take hex bolts through the bottom of them to hold them in place. And the more complicated bit is how you attach the wheel, because if you take all this out of a drill, you end up with a little threaded piece on the end. So, what I did was I found some little nuts, well, hex nuts about this long, that fit on there, screwed that on, and then, because I had access to nothing but a shed of some 20-year-old tools, I put that into a drill press, put the wheel down below, and slowly pushed it down, and after heating it up on my kitchen stove, heat pressed it into this. So there is now a hexagonal heat pressed nut inside this. So if it's heat pressed and stuck, why does it have a bolt in it? Because the heat press wasn't enough. We had multiple fights early on, and you can see the videos on this channel where the wheels would come flying off if we drove too quickly and turned a corner too quickly. So we cut a little bit of a hole to make it easier to fit a washer in here, put a washer in, stuck a nut through, and since then we've never had a wheel problem. Unless, you know, they got torn in part by a spinner, as Neon did to the lawnmower we took to the last Extreme Robots. Thanks, Neon, that was fun. As you can see, this has been on here a while. This damage, this hole here, was from a robot, Oddbot I believe, in 2017. This wheel has not been changed in 3 years because it still works perfectly, it's just got a hole in it. The only thing that doesn't always work perfectly is these motors. A couple of them have a dead spot in them now where they will just freewheel. Though apparently not this one, probably the other one that I haven't taken out yet. And they can freewheel slightly. Can be a problem. It's not enough to warrant changing it, and this thing wasn't designed to win anyway. It was designed to have fun. So let's take the last bits of the chassis apart, and then we'll see what we've got left over to build something new. So, this is the pile of stuff that was BAW1. And now we have to figure out what it is we're going to do to make something new. So, what do we have? We have the old wiring loom, which doesn't really need to be touched. It can just be screwed back into whatever we need, unless I decide to tidy it up, but not really necessary. We've got our 2 drive pods with the appropriate bolts to hold them in place. We've got a couple of hinges, just garden gate hinges. They were what allowed the top to open and close on BAW1, and they're screws. We've got a load of these small wood screws, about this size, ranging up to 2 we've got which are much longer. They were what held the top down before. We've got all the fixings and stuff from the old internals, from these carriage bolts to bent piece of metal that was used to hold the plug in place. Some sponge for padding, which I think I've got more of somewhere. And then we've got all this, bits of wood, bits of plastic that made up the old chassis. So let's space this out. I'm going to think about what we're going to do, and then we'll get to building. Okay, so I think I have a plan for what we're going to do. We are going to keep this as simple as possible with as much of it as recycled material as possible. We are going to build a box on wheels. Yes, that's right, your classic box on wheels that forms the basis of every combat robot from the 90s. But with everything I do, I like to try and learn something different. BAW1 was an exercise in could I build a combat robot. Bolts, the nuts look-alike flailbot, was an experiment in could I build something with a damaging weapon. The answer was nah. And BAW2 and 2.1 were experiments in could I use welding and build a metal chassis. So, what is this box on wheels going to have different to everything else? Well, I want to have a go at hinged wedgelets. Now this is of course a move away from the fixed wedge to something that should, in theory, be better at getting under people. But I'm only going to be able to do it with recycled parts from BAW1. So what have we got that we can use as hinged wedgelets? Well, hinges. These are floppy enough that I'm pretty sure if I bolt that onto the front of a chassis, it will stay on the floor no matter what height it's at. So you can go over bumps and it will always return to ground scraping. Now of course this end is a bit blunt and thick to be a wedge, so it will need filing down to a point, which brings me to my next point. Point twice. Anyway, the only power tools I have available to me at the moment are this drill and a jigsaw. That's it. Those are the only two power tools I have, and that is because I have recently moved house. I was, at the start of this pandemic, and for the past few years, living mostly with my parents. But last year I went away to university for 6 months, things got cancelled early because of a global pandemic, and I moved back home. That gave me plenty of access to my dad's collection of 20-year-old tools. Now I am out living on my own for the next 2 years, 3 years, hopefully, if I finish my course. But that means I don't have access to my tools. In fact, the only thing I have access to, if I carefully lift the tripod, is that toolbox there. That has a load of hand tools in it, that has a load of screws and bolts and fastenings in it, and the only excess material I have is this spare bit of plastic that goes all the way down to the ground, this bit of wood here, well, these 3 bits of wood, this angle steel, and somewhere, I believe, a small piece of round bar. But I want to try and use as little of that as possible. There we go, back in place. Ooh, that's reflecty. Anyway, stop getting distracted by the camera. But I want to use as little of that recycled material, or that material over there, and want to use as much recycled material from BAW1 as I can. So, with that said, let's get this build underway. So step 1 to building any robot is your base plate. You need to know on a flat plane, can you fit everything you need to inside the robot? And normally this involves getting a piece of paper or cardboard, laying out all your components, drawing around them and making sure everything fits. But because we're recycling an existing robot, I already know that all my parts fit in this back square. So I think step 1 is going to be just cut away the excess from all this front piece, and then we'll have the base plate. But of course before, what we had was a rather large block making up the back piece. There. That took up a lot of space. That is a very thick piece of wood. And while that makes for excellent strength and defense, it's not necessary anymore because we're not putting hinges in it, which you can see where the hinges used to be. So it doesn't need to be quite so rigid because it's not supporting as much anymore. So I think that will be the first place we're going to use either some of this, if I can get it actually square, but considering the rickety cuts, possibly not, or some of that wood from over that way, which I said I didn't want to use, but well, makes life easier. So we can probably shrink this down by about half as much at the back as well, cut down some of the sides, and this will be the basis of our box. So, with that said, let's get everything cut and we'll see how big it looks. So, now we have our base plate for our new box on wheels. It has been cut down, the bits have been cut off here, and a strip cut off the back to make it the right width for the back. And with the amount I have left over, being all of this, which does fit entirely around it, I'm pretty sure we can get the height we need to make sure we can get the walls out of this recycled material as well. And that is because the tallest thing inside there will be this, the drive pod. And measuring this up, it looks to be, that's the wrong measurement, about 55 millimeters in there. So call it 60, so we know we've got the extra space. We can always cut it down, we can't make it bigger. And 60 millimeters fits all the way along sides like this. And up the side here as well. Yep. We can pretty much get 60 millimeters almost anywhere we like out of this. And remember, I've got this as well, which is the top panel. So what I'm going to have to do is measure the square I need out of this back piece, and then measure the sides out of these, and then I'll have a top plate and some side plates. Okay, so we now have our side pieces cut and our top piece cut, which means we now have essentially a box. Like that. Holes, of course, for... Good job, me. Holes, of course, for the wheels to come out of. One thing you may have noticed is that this piece has a couple of corner bits on it, because it needs to be slightly wider than the back of it actually is. And yeah, it started to fall apart while I was cutting it. Don't question that. Anyway, so now what we have is a slightly off-cut, weirdly shaped square. Well, rectangle. And this, of course, is going to be the basis of all of our things. And as I can see from looking in here, all of the screw holes that need to be there for the internal mounts from last time are all visible. So, it looks like we now have our main chassis, which I would imagine, if I just lay everything on top of each other, yeah, it really doesn't weigh much. That's probably 3, maybe 4 kilos, maybe slightly more. I'm not good at judging weights, but that is way, way, way below the weight we need, which of course it will be, because it's made of scraps of a robot that was within the weight limit. So, I'm now starting to think, can we make this even lighter? Would it be possible? Depends, I'm going to try and see, to not use this top plate, but instead just have a plastic cover on top, which is what we did for bolts. That would make it even lighter, because the lighter I can make this, the more chance it can become one half of a cluster bot. Now, I can't remember how heavy bolts is. I think it was about 7 kilos last time I checked, but that would leave us with about 6 to build this, and the 2 could become a cluster bot in theory. Now, in reality, I don't think it would be bolts. I'd have to build something else lighter. But let's screw all these pieces in place and see what we come up with. Okay, so I've skipped ahead a step, but we have our sidewalls now on. 1, 2, 3, 4. As you can see, they're all just screwed in with screws around the edge underneath. But what I've also done is put all the coach bolts back in and put in the wheels with their hex nuts. So, we are starting to lose the light today, so I think I'm going to have to call it here for today. But I will return in what for you will be about a second, but for me will be a few hours to the next day. Okay, so it is now the next morning, well, about midday. It's sunlight outside again, which means I can see what I'm doing and the camera can see better. And I think today is going to be the day we get everything finished, at least I hope, because we can now at least have some semblance of what this is going to look like when it's finished. Because if we now put the lid on and get our 2 hinges, we can now see vaguely what the robot is going to look like when it's finished. And I think when you can actually physically see what it's going to look like, you know you're getting somewhere close. Unless, of course, a million things pop up in the meantime to tell you you're doing wrong. Which, there is one thing I've done that I always do, and it's very much in the scrappers tradition. I never measure anything properly, because I don't want things to look neat, I don't care. My whole point is to prove that anyone can do this without any skill, and if that skill includes complete stupidity, well, that's gonna be how I do it, because I cut this box thinking, hey, all the brackets and everything fit in, everything must fit. But no. What I didn't consider, of course, is that the battery goes long ways. There's not actually quite enough room for the battery. It will either press against this wall or sit up a little bit on these mounts. So that is something I'll have to deal with. either by carving a little router gap into the back of this wall here, or by trying to trim off the front of these mounts, but that's not a problem for today because all I want to do today is get the plastic on, get these hinges on the front, and then give it a test drive to prove it works, because anything after that is troubleshooting, and troubleshooting can be done anytime, not during the build process. That's how I justify my failures to myself. So, let's start by getting this possibly slightly sanded down, because the front sticks out a little bit. There's a little lip here. Go around all the sides, make sure everything's mostly flat, and I think it is literally just, yep, that one side that needs trimming slightly. Decide whether or not we're going to bother to put this on top or just go straight for a plastic lid. With how off square this is, I'm thinking we may screw it on for testing and then go with the plastic lid for simplicity's sake later on. Also, I'm running out of longer screws to use for this recycled project, and I don't want to dig into the bag of screws I have because that would defeat the point. So I think we're going to go straight up for a plastic lid for the top, put plastic on the other sides for extra defence, because to be fair, we should be getting hit front, preferably not sides, hopefully not the back, but we'll almost certainly get hit underneath at some point, so they'll need the extra protection. In theory, we shouldn't take too much damage to the top, and if we do, the hammers I usually fight against aren't the best at getting through the 10mm HDP that we have, mostly because they're flat blades, not pokey sticks, and the plastic can defend against that quite well as I slowly pull little splinters off the edge here. Should have sanded that. Oh well. So, plastic cut, I'll be right back. Okay, so all the side panels are on, the bottom panel's on, top panel is right here. If you can hear a lawnmower in the background, I'm sorry, my neighbours have started mowing their lawn and, well, I don't have time to wait for them to finish, and I'm not going to go ask them to stop because that would just be rude. So, we now have all four bottom and then all four side panels on, and as you can see, the old wedge, which had this sticker on it, is just the right size to fit on the front and on the sides. So 2 of these panels came from the old wedge and 2 have come from the old base plate, which now looks like that after everything's been cut out of it. We also have the bottom plate, which is just a rectangle, and the top plate is here. It needs shaving down slightly because it's too slightly too big. It sits up on this ridge and it should sit down behind it, but that's okay. That can be shaved off either by hand or by jigsaw. I don't know, it depends how much time and effort I really want to put in. But I think the next step is to put our 2 hinges on the front and just see how well they sit and if they're actually going to scrape the ground like we really want them to. And there we go, hinges on. And now you can really see what this is going to look like. Obviously the benefit of hinges is no matter what angle it sits at, these stay on the floor. Now at the moment they won't be very effective because they're so blunt and quite thick. They're probably 2mm thick, let's have a look. About 3mm, because these are designed to be sturdy gate hinges and not designed to be wedges. But you'll notice I have put them about 2/3 of the way up because they have more movement in one direction than the other because, well, they're hinges. But hopefully, if I flip it over, there you go. They're also ground scraping the other way for pretty much the entire range of motion you could get. So we have 2 ground scraping wedges. That's really what this whole recycling experiment was all about. It was about doing something new with what I had. And what I had was a couple of hinges, some wood, some plastic, and a load of electronics. And I'm quite happy with how we've done this. So I think, ignoring the fact that the top plate doesn't quite fit because I need to shave it down to size, I think we're about ready to give this a little test drive and just see if it works the way I hope it does. Okay, so we're outside on the ground, plugged in, everything seems to be working. Obviously the electronics aren't secured properly and the top's not on because this is just a quick first test. Let's see how we do. Okay, forwards and backwards are the wrong way around. Oh well. Ooh. And that's why you secure everything down. Let's make sure that battery's back in properly. That's why I'm only doing this at very, very, very minimal drive. There we go, slightly stuck on a bump. Now that's the one thing we do want to avoid with hinge wedges. which is the slight advantage of having so much thrust that can lift the front up if you go fast enough. Overall, I think that can be considered a very successful first test. All that's really left to do is make sure that top panel fits, make sure the electronics actually fit and bolt in, which I think will be take a wheel out and shave something off the motor mount, just so the battery fits in properly. If not, I can possibly twist some things around and mount it slightly differently. Oh well. But this was a quick, I think, what, 6 hours I've spent on this total, from before I first picked up the camera to what you're seeing now. So I think this is pretty good, fun little build, and I guess we'll wait and see when competitions are a bit more back to normal just how well attaching some gate hinges to the front of a box does. But I hope you've enjoyed this quick look at how to, well, recycle more than build from scratch a combat robot. The only thing that wasn't really explained in this video was how to do all the wiring and everything, because I just didn't need to. There's videos from the Witch Doctor team from BattleBots. Those are in the playlist I mentioned before. They are a brilliant explanation of how the electronics works. Anyway, that's how to build a box on wheels with hinges in 6 hours. Thank you very much for watching, and I'll see you at our nearest competition.